All right, this is 2017 number 4. It has 3 parts. I'm going to just try and do each part on a page here. So we'll start off with A, but let's just read it. Okay, so at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool. So its temperature is going to be decreasing. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. They're going to articulate this for us better here in calculus terms. And the internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. So that's probably like room temperature or whatever. You know, it's as it goes down in temperature, it's going to get closer and closer to 27, but it won't actually cross 27 because it's not like the room's going to make it colder than the room itself. The room's not going to make the potato colder than the room itself. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation. So they just give us the differential. We don't actually have the equation for h, where h of t is measured in degrees Celsius. And hey, look, h of 0 is 91, which they already told us up here. So let's go through it. It says, write an equation for the line tangent to the graph of h at t equals 0. Easy. Use this equation to approximate the internal temperature of the potato at time t equals 3. Easy. So let's just remember what a tangent line looks like. For tangent lines, we like to use point slope form. That's point slope form. But the only thing that's tricky is that m is usually going to be the derivative. And in this case, it's going to be dh dt. When do we want it? We want it right when t equals 0. So at t equals 0. So let's do that first. Let's figure out what is dh dt when t equals 0. Well, they gave us the equation for dh dt, so let's just plug in 0 for t. The only problem with that is there's no t in your equation, right? There's no t here. There's just an h, but we know what h is when t is 0. So really, we're plugging in a 91 for h. We're not really plugging in a 0 for t. We're just plugging in a 91 for h because that's what h is when t is 0. So what does that look like? That looks like negative 1/4 91 minus 27, and just got to simplify. 91 minus 27 is 64, so I got negative 1/4 of 64, which is negative 16. Okay, so we just found the derivative, which is really our slope, right? So we just found that part, okay? And you may not recognize it, but they already gave us the other parts. Look, that's like your x1, and that's like your y1. Boom. So let's go ahead and write that equation now. So we could say something like y minus y1, we already said is 91, equals, we already got that slope is negative 16, and we could just say x minus 0. Okay, that's good enough for part 1 of A, but remember there's more to it, right? Remember they said not just write out the tangent line. Now we want to use this equation to approximate the internal temperature of time t equals 3. Well, to really approximate this thing, we got to get y by itself. So what would that look like? Again, we don't have to get y by itself to write the tangent line, but to approximate it, we kind of do. So that would look like negative 16x, and then you're going to, and that the 0 just disappears, right? Negative 16 times 0, 0. And then just add 91 to both sides, so it would look like that. So that's actually, you know, a little bit simpler, a little bit more usable tangent line equation. And it's really useful when you want to approximate. So if you wanted to say, hey, so what is h of 3? Well, it's approximately what we called y. So it's approximately y of 3, which is negative 16 times 3 plus 91. And negative 16 times 3 is negative 48. And just a little quick note, the way I kind of do that in my head is I say, okay, I don't know what 16 times 3 is, but I do know that if I cut that in half, that's 8, and if I double that, that's a 6. And so 8 times 6 is going to be the same thing as 16 times 3. So that's 48. So that's negative 48 plus 91. And to get from 48 to 91, you get to 50 to 90 is 40. And then from 8 to 50 is 2. And then 90 to 1 is another 1. So that's looking like 43. So use this equation to approximate the internal temperature at the potato at time t equals 3. I think it's 43 degrees Celsius. So I think h of 3, it's an approximation, and they told us that. That's an approximation. And that's linear approximation. We did that a long time ago, but in case you forgot, that's just using a tangent line. I'll do like a quick little recap, right? That's just saying, like, let's say you have some curve and you have a tangent line, right? we're really close to the tangent line, right? If you want to know what this value is here, if you want to know this blue value, then this green value is probably pretty close to the blue value. But the farther you get away from the point of tangency, obviously the farther away these points would be. But if you're really close, which we kind of are here, right? Because 3 is pretty close to 0 for the sake of this problem, then we can say, like, okay, that's a pretty good approximation, or decent enough for this question. All right, let's go to part B. Okay, so part B now says, use the second derivative to determine whether your answer in part A is an underestimate or overestimate. So I just did a quick sketch last before, and I didn't really know if it's an over or under, but we will at the end of this part, of the internal temperature at T equals 3. So let's use the second derivative. So let's go ahead and do the second derivative. So here's the first derivative. If I was to do the second, it looks something like this. I'm just going to do it kind of implicitly for now. So it would equal what? Well, the first thing I would do here is I would kind of just do this, just to kind of help you visualize it. If you distribute that negative 1/4, you could see how the original equation would look something like that. And so what's the derivative of that? Well, that's just negative 1/4. Derivative of h is dh dt, right? And then the derivative of 27 over 4 is 0. And I forgot the little 2 there. So let's just take this. So let's just take this guy, which is dh dt, and just plug it in for dh dt, right? So what do I get? Well, I'd get that the second derivative is negative 1/4 times negative 1/4 times h minus 27. Okay, well, negative 1/4 times negative 1/4 is positive 1/16. And that's going to be times h minus 27. Okay. So what are we supposed to do with this? We're going to use this to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at T equals 3. Okay, so there's some information in this original problem that might be really helpful, and that is right here. They told us that the internal temperature of the potato, which is H, is greater than 27 for all times T equals 0. So this value here cannot be less than 27. It can only be greater than 27, which means if you do something greater than 27 minus 27, you're going to get some positive value here, right? You're going to have to get some positive value here. So you're going to get 1/16 times some positive. Well, that's really a positive times a positive. So this is always going to be a positive. That's all that really matters, is that this is always going to be positive. There's never, the only way you get a negative here is if somehow this number was like 26, right? 26 minus 27 would be negative 1. But they told us in the problem that can't happen. So this makes it actually pretty simple. It's always going to be positive. That means that this curve is concave up. And if it's concave up, our tangent line would have to be underneath that. So we could say something like, since the second derivative is always greater than 0, the approximation is an underestimation or an underestimate, something like that. And I think that would be plenty for that question. All right, part C now. It says, for T is greater than 10, an alternate model for the internal temperature of the potato at time T minutes is the function G, okay? And that function satisfies this differential equation. So we got a new differential equation we're going to look at, where G of T is measured in degrees Celsius, and G of 0 is still 91. Okay, so they have the same starting point. Remember, H of 0 is 91, so is G of 0. Find an expression for G of T based on this model. What is the internal temperature of the potato at time T equals 3? So this is just separation of variables. So I'll show you how we do this. I'm going to zoom in on the actual equation. We're going to kind of just play with this a little bit, because can't I just say, couldn't I put the dg here and then divide, take this whole thing essentially, and like divide both sides by it, and that would be this. and then at the same time, I could multiply both sides by dt. And essentially, this and the dt would just switch places. And then I could rewrite this a little bit. I could make this a negative of g minus 27 to the negative 2/3 dg equals dt. And the only reason I'm rewriting that is just so you kind of see it a little bit better, right? Because now I could just do this. And I could take the integral of both sides. And I left the negative on the outside of the integral because we can do that. It's just kind of a coefficient. And so let's think about what that would be. We do have a little bit of, it's not really going to be a chain rule, but you could kind of think of this as a chain rule, but there's no coefficient in front of g, so it's really not that bad. So just simple integral, right? What do? Well, we add 1 to the exponent, so negative 2/3. If you add 1, that's going to become positive 1/3. It's already negative out here. And then you divide by the new exponent, which is the same thing as multiplying by 3. So I'm just going to put a 3 here. Okay. Equals, well, what's the integral of just dt? That would just be t, and then we're going to have to account for a constant somewhere. So there is some constant. All right. Let's back up. Why are we doing this? Well, we're trying to come up with g all by itself. And look at this. They gave me some very important information right here. They told me g of 0 equals 91. So zoom back in. If g of 0 equals 91, we know that when the time is 0, the g is 91. And remember, the t is 0 in this situation. Should have done that in red so you could see where it came from. This came from here. Okay, so 91 minus 27, well, it's still 64. And 0 plus c is c. So what's a third root of 64? Well, it's just 4, right? Because 4 to the third power is 64. So this is negative 3 times 4, or negative 12. So our c value is negative 12. So let's go back to this line here. We could say negative 3 g minus 27 to the 1/3 equals t. Instead of plus c, I'm going to write minus 12. Because of there. All right. Now we're almost done. We just have to get g all by itself, and then we're going to plug in a 3 to find out what is the actual temperature at 3. And it kind of tells how good our approximation is. So let's work on getting g all by itself. First thing I see is this negative 3 out here. I don't want it out there. Let's go ahead and divide everything by negative 3. And so now I have g minus 27 in parentheses to the 1/3 equals t minus 12 over negative 3. I could raise everything to the 3rd power. And so I have g minus 27 equals t minus 12 over negative 3 to the 3rd power. And then I could add 27 to both sides, right? Okay, and so now I have g equals t minus 12 over negative 3 all to the 3rd power plus 27. Hey, you know what? That looks like an equation for g. Okay, and then remember it says based on this model, what is the internal temperature of a potato at time t equals 3? So we just need to plug in a 3. So what is g of 3? So what is g of 3? G of 3 is 3 minus 12 divided by negative 3 to the 3rd power plus 27. 3 minus 12 is negative 9. You can kind of see what's going to happen here. Negative 9 divided by negative 3 is positive 3. 3 cubed is 27. 27 plus 27 is 54. So this thing is 54 degrees Celsius. And I think we are done. Let's see. Find expression g of t. We did that. Based on this model, what is the internal temperature of the potato at time t equals 3? We did that. Boom. All done.